Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P0133, indicates an issue with the air-fuel AF sensor, specifically sensor 1. This sensor plays a crucial role in monitoring the air-fuel ratio of the engine, ensuring that the ideal mixture is maintained for optimal combustion and emissions control. Typically located in the exhaust system, upstream of the catalytic converter, sensor 1 evaluates the oxygen content in exhaust gases, sending feedback to the engine control module, ECM. When the sensor malfunctions or exhibits a slow response, it can lead to performance issues such as reduced fuel efficiency and increased emissions. Understanding this code is vital as it directly impacts the engine's operational efficiency and compliance with emissions regulations. Therefore, troubleshooting this code is necessary to maintain vehicle performance and longevity. DTC P0133 signifies a malfunction or slow response from the AF sensor 1, which critically affects the air-fuel mixture required for optimal engine performance. This sensor is situated in the exhaust system, often before the catalytic converter, allowing it to accurately gauge the oxygen levels in exhaust gases. Its role is vital as it relays real-time data regarding the air-fuel ratio to the ECM, facilitating adjustments based on driving conditions. A malfunction can lead not only to performance issues, such as sluggishness or misfires, but also adverse effects on fuel economy and emissions levels. Addressing this DTC promptly is crucial to restore the vehicle's efficiency and compliance with emission standards, making this component a focal point in troubleshooting efforts. The possible causes for DTC P0133 include a faulty AFAC sensor, wiring issues, or a malfunction within the engine control module, ECM, or powertrain control module, PCM. A faulty sensor may not accurately detect the air-fuel ratio, leading to incorrect adjustments. Wiring issues, such as damaged wires or poor connections, can interrupt communication between the sensor and the ECM, resulting in signal loss or distortion. Additionally, an issue with the ECM or PCM could misinterpret the data received from the AFAC sensor, further complicating the situation. Each of these causes contributes to the slow response condition that the DTC describes, making comprehensive inspections of all components associated with the AFAC sensor vital to correctly diagnosing the problem. Symptoms associated with DTC P0133 may manifest as poor fuel economy, rough engine idle, or increased exhaust emissions. When the AF sensor is not operating properly, the engine may run richer or leaner than optimal, leading to decreased fuel efficiency as it struggles to maintain the required air-fuel ratio. Additionally, a rough idle can occur as the engine's management system attempts to compensate for the malfunctioning sensor signals, resulting in unstable engine performance. Since the AF sensor plays a pivotal role in emissions control, increased emissions may also be a consequence, potentially leading to failing emissions tests. Recognizing these symptoms can facilitate earlier interventions, preventing further damage and ensuring compliance with environmental standards. The first step in troubleshooting DTC P0133 involves turning the ignition switch to the on/I position, which powers up the vehicle's electrical systems. Following this, the diagnostic system Honda HDS should be used to clear previously logged DTCs, including P0133. After clearing, the next critical task is to start the engine and stabilize the engine speed at 3,000 RPM without load, ensuring that the automatic transmission, AT, is in Park P or neutral, N for automatic transmissions, or neutral for manual transmissions. This step is essential as it allows the engine to warm up and the radiator fan to engage, helping to simulate a normal operating condition that will offer insightful data for further diagnosis. It's critical to monitor the conditions closely, as the radiator fan's activation indicates the engine has reached a certain temperature, which is necessary for real-world testing. In the second troubleshooting step, a test drive is conducted under specific conditions to assess the vehicle's performance and monitor for DTC P0133. The engine coolant temperature, as measured by sensor 1, must exceed 158 degrees Fahrenheit, 70 degrees Celsius, for the test to accurately reflect normal operation. The vehicle should be driven with the automatic transmission, AT, in drive, D, or the manual transmission, MT, in third or fourth gear, maintaining an engine speed between 1,500 RPM and 3,000 RPM. Furthermore, it's vital to drive the vehicle at speeds of 25 miles per hour, 40 kilometers per hour, or less for the first 5 minutes, followed by maintaining a steady speed of about 32 miles per hour, 52 kilometers per hour, or more. This structured driving process allows the vehicle systems to enter different operational phases, allowing better observation of sensor behaviors and ECM responses, which is critical for diagnosing the malfunction accurately. Following the test drive, the next step involves monitoring the onboard diagnostics (OBD) status using the HDS. This tool will help determine if DTC P0133 has failed during the diagnostic process. It is crucial to assess the output effectively. If the HDS indicates that P0133 has failed, you will proceed to the next step in the troubleshooting process. However, if the code shows passed, this may imply that the system is operational at that moment, even though intermittent issues might exist. In such cases, an examination of the A-F sensor and the engine control module (ECM) connection is needed, focusing on any loose terminals or connections that may have impacted system performance. The proper documentation of these statuses provides important clues for resolving the issue, forming a solid foundation for any subsequent actions. If the monitoring step confirms that DTC P0133 has indeed failed, the next step is to turn the ignition switch to the lock 0 position. This precaution is essential for safety before proceeding with any repairs or component replacements. Subsequently, replace the AF sensor 1, ensuring that the new sensor is correctly installed and is compatible with the vehicle's specifications. Once the installation is complete, turn the ignition switch to the on 2 position again to initiate a fresh diagnostic procedure. Ensuring a correct fit during sensor installation is crucial, as an improperly connected sensor can lead to further issues or erroneous diagnostics, thereby complicating the troubleshooting process. This step sets the stage for re-evaluating the system in continuity with the ongoing diagnostics. Upon replacing the A/F sensor 1, the fifth step mandates resetting the engine control module, ECM, or powertrain control module, PCM, with the HDS. This is crucial as it clears any previous settings or error codes, allowing the engine management system to recalibrate itself with the newly installed sensor. Following this reset, the ECM/PCM idle learn procedure must be executed to ensure that the engine learns the base idle speeds necessary for optimal performance. This involves observing the engine at idle to allow the system to gather data on how the new sensor performs in real-time conditions. Proper execution of this reset and learning procedure is vital, as any discrepancies here could lead to further confusion in diagnostics or sustained performance issues, potentially causing intermittent DTCs in the future. In this step of troubleshooting, restarting the engine is essential. followed by maintaining the engine speed again at 3,000 RPM without load, similar to the earlier steps. Ensuring that the engine is held at this specific RPM allows verification of the newly installed AF Sensor 1's effectiveness in real-world conditions. Monitoring the engine's performance during this period is crucial, as it helps assess how well the sensor is responding to the changes in the air-fuel mixture. If the system operates as expected, it can signify that the P0133 issue has been resolved, while any anomalies here could indicate potential lingering issues or improper installation of the sensor. This practical observation effectively bridges the gap between diagnostics and real-world applicability, solidifying the need for thorough checks. The final troubleshooting step is to conduct another test drive replicating the specific conditions as before, following the protocol for engine coolant temperature and transmission gears. During this test drive, it is crucial to check for the presence of DTC P0133 again, using the HDS to assess if the code resurfaces after the sensor replacement and ECM reset. If P0133 is indicated, it suggests that underlying issues could still be present and may require further investigation into wiring, connections, or even the replacement sensor itself. Conversely, if the fault code is absent and the system indicates passed, it suggests that the troubleshooting procedure has effectively resolved the initial problem. Continuous monitoring for any new pending or confirmed DTCs is advisable, emphasizing that the ongoing health of vehicle performance is critical to environmental compliance and operational integrity. Final repair verification is an essential part of the troubleshooting process for DTC P0133. At this stage, checking the onboard diagnostics (OBD) status with the HDS is crucial to ascertain whether any fault codes persist after completing the repair steps. Confirming that the status is passed indicates that the vehicle systems have returned to proper functioning, and the air-fuel mixture is being accurately monitored by the newly installed sensor. Additionally, reviewing the sensor performance and ensuring that all connections remain secure helps validate that previous issues have been effectively addressed. This comprehensive verification process not only ensures customer satisfaction, but also maintains vehicle viability for meeting emissions regulations, reinforcing the importance of diligently following up on corrective actions. Preventive maintenance is crucial in the longevity and efficiency of the AF sensor and related systems in your Honda Accord. Conducting regular checks on the AF sensor should be part of the vehicle's routine servicing schedule. This includes inspecting the wiring and connectors for signs of wear, corrosion, or damage that could lead to issues in the future. Routine engine diagnostics using the HDS can help detect early signs of malfunctions before they escalate to more significant problems like the DTC P0133. Following the manufacturer's guidelines and scheduling regular maintenance not only helps ensure optimal performance, but also mitigates the risk of environmental non-compliance due to emission control failures. Regularly reinforcing these practices keeps your vehicle innovative and reliable in tight operational phases. In conclusion, understanding the role of the AF Sensor 1 in the Honda Accord is vital to diagnosing and resolving DTC P0133 effectively. Through a systematic approach to troubleshooting, from symptom recognition to executing repairs, we can ensure that vehicles perform optimally while adhering to emission standards. The outlined steps provide a comprehensive framework for addressing the issues associated with this DTC, highlighting the importance of monitoring and verifying performances after repairs. Moreover, the emphasis on preventive maintenance underscores the vehicle owner's responsibility in promoting longevity and functionality. Ultimately, maintaining awareness and responsiveness toward these technical aspects leads to enhanced driving experience and environmental consciousness, while ensuring compliance with regulatory requirements. Please like and subscribe to the channel. See you next time.